Hello, my name is Alfonso, and my partner's name are.
Hello, my name is Guillermo Flores.
And my name is Erasmo Sanchez.
And the title of our poster is TiO2 or C3N4. Which of the photocatalysts has the best quality to degrade organic dye molecules? The purpose of our research is to determine how a photocatalyst can degrade harmful pollutants within the water sources. Though water pollution has become a major issue, mainly caused by the textile industry, which then releases harmful dyes and chemicals into our water sources. In this research, we will be comparing two different types of photocatalysis, TiO2 and C3N4, to see which of works best to help rid water pollution. And the term photocatalysis means photo means light, which is energy from the sun, while the term catalysis is a chemical material used to accelerate the reaction.
In order to conduct our experiment, we first needed to prepare our solid catalyst C3N4 or carbon nitride. Chemical melamine was used and the calcination method was put in practice in order to synthesize carbon nitride. This method consists of heating melamine at very high temperatures inside a furnace. After synthesizing our photocatalyst, we then needed to prepare our diluted solution. In order to do this, 5 millimeters of rhodamine B was transferred to a 500 millimeters Erlenmeyer flask. Then 495 millimeters of water will be added to the same flask. As a result, we will have 500 millimeters of our diluted solution. We can view this in figure 1. The next step is to add 50 millimeters of our diluted solution to a new Erlenmeyer flask. Also, 0.52 grams of our photocatalyst was also added. There will be a total of 5 samples with the same amount of every solution, except that one of the samples will contain a metal ion called nitrate. Moreover, the 5 Erlenmeyer flask will be put above 5 different hot plates. Then a stirring bar will be also added so it can move inside the flask so it can stir the solution with the help of the hot plate, which also works as a stirring machine. We can view this in figure 2. 4 of our samples will be exposed to different light sources. The first sample will be exposed to the first sample will be covered with a carbox. The second sample will be exposed to natural light. The third sample will be exposed to a 40 watts light bulb. The fourth sample will be exposed to a UV LED lamp, and the fifth sample will be similarly exposed to a UV LED lamp. However, will contain a metal ion called nitrate. We can view this on figure 3. After 30 minutes, the photocatalyst will be able to degrade most of the contaminant found in the diluted solution. The centrifuge was then used to separate the solid catalyst from the dye solution. We can view this in figure 4. The spectrometer was then utilized to identify the concentration of our organic dye molecule found in the samples. The least amount of light absorbed, the least amount of dye concentration inside the sample. The data that was collected is the following. In the first table, we can view the light absorption in percentage of the 5 samples where titanium dioxide was added. In the second table, we can view the light absorption also in percentage of the 5 samples where carbon nitride was added.
Now to the discussion / results. The first project was going to involve a solid catalyst named zinc oxide, but the pandemic prevented the acquisition of this substance, so we started with a new project that involves C3N4 and TiO2. This research is to determine the better photocatalyst at degrading rhodium B. If we look at the tables, we can see that C3N4 was a better photocatalyst. If light absorption is high, then dye concentration is still high. However, if it's low, then dye concentration is low. Throughout the experiment, rhodium B had a pink color when mixed with water. After photocatalysis, our samples became lighter because the solid catalyst had started the dye molecule, changing it to lose its color in water. Additionally, the solid semiconductor utilizes photon energy from the light to get excited, and this produces some active species. It was noticed that these active species are important because they cause a degradation of dye. Furthermore, the UV light had better performance than other light sources because its photon energy was stronger than the other ones. So to conclude, a photocatalyst serves as a very good tool to degrade organic dye molecules that can negatively impact the environment. Throughout this experiment, two different solid catalysts were compared. Carbon nitride and titanium dioxide have been very good photocatalysts that effectively work. However, in this research, the solid catalysts were compared to see which has the better quality to degrade dye solutions. From the research made, it was understood that carbon nitride is more efficient than titanium dioxide because it was able to decrease a high amount of dye concentration found in the samples. Also, the help of a metal ion named silver nitride improves the results because it helps the photocatalyst degrade more of the dye solution. Now, at the bottom center is our references, and at the bottom left is our acknowledgements. Thank you.